So plants, creatures that we don't normally associate with any kind of cognition or mentality, have evolved mechanisms that allow them to be sensitive to parameters in their environment and then to adapt to that environment to increase their chances of surviving or thriving. But these kinds of mechanisms, this information imperative, goes even lower down the evolutionary ladder. And the next stop that we want to look at is magnetotactic bacteria. Now, magnetotactic bacteria evolved roughly 1.1 billion years ago, and they are ambulatory bacteria. They have little flagellum, hair-like structures that allow them to move around, but they also have a small ferrous compound, that is a bit of sort of iron, that allows them to be sensitive to the Earth's magnetic field and to orient themselves towards magnetic north along the magnetic field lines. And by having this little compass essentially inside of them, they are able to figure out where they are in a body of water and a bit of silt. Now, magnetotactic bacteria are all anaerobic bacteria. That is, they thrive in conditions where there is little to no oxygen. And so what they want to do is swim towards the conditions that have the least oxygen and away from the potentially toxic oxygen-rich environments. And usually that means swimming down deeper into the lower levels of the water or into the deeper levels of the silt. And so these magnetotactic bacteria use their geotropism, their sensitivity to the Earth's magnetic field, to orient themselves and then to swim towards the oxygen-poor environments that they thrive in. Now, these mechanisms, like the phototropic mechanisms, are very simple biomechanical irritability mechanisms. They can be easily fooled, and magnetotactic bacteria, as we'll see in this next video, are easily fooled when you put magnetic fields around them and distort their ability to sense the Earth's magnetic field. What we're seeing in that little video there, which might be obscured by the overly dramatic music in the background, is a graduate student at Woods Hole has a bunch of magnetotactic bacteria in a dish under a microscope, and they're moving a magnet around. And that magnet is locally stronger than the Earth's magnetic field, and hence the magnetotactic bacteria think that magnet is geological north and swim towards that magnet wherever the graduate student happens to put it. So these magnetotactic bacteria, they have an information imperative, they have a mechanism of irritability. That mechanism is very primitive, and hence they are easily deceived. It's not very well calibrated. Additionally, it doesn't actually have a sensitivity to the parameter in their environment that they really want. They're keying on magnetic north because magnetic north is associated with their ability to go to oxygen poor levels, to swim away from oxygen rich surface levels. But they're not actually sensing oxygen, which is the thing that they really want to be able to avoid, and hence they aren't really sensitive to the parameter in their environment that would be the most useful to them.